Okay, video recording started. Okay, now of course this is from the textbook. So let us start solving the problems. In all the problems in this particular course, so since we are referring this textbook, which is Fundamentals of Microelectronics by Behed Razavi, uh, who is there with me? Nivedita, no?
Nivedita.
Yeah, Nivedita. Now we can see
Yes, sir.
in the following
Yes,
problems,
sir.
unless otherwise stated, assume mu n Cox is equal to 200 microampere per volt square and mu p Cox as
Yes,
100
sir.
microampere per volt square. Mu n stands for NMOS, mu p stands for PMOS. Correct?
Yes, sir.
So far we
Yes,
have
sir.
not discussed PMOS. So let us only consider mu n Cox as 200 microampere per volt square and VTH as 0.4 for NMOS devices. Okay. So what I want to say is,
Yes, sir.
let me also share share content in terms of camera. Is both camera and this are visible? Let me make. Okay, just a minute. I'll make both of them visible. Okay. Is Tanuja there? Hello, Tanuja.
Yes, sir.
Oh, where were you in the morning?
Sir.
No, it doesn't mean that you need not have to answer it. When I say you have to unmute yourself and then talk. What was the problem? Were you there? Okay, simply switched on your what? What was the problem,
Sir,
Tanuja?
network issue.
Network issue again. As I told, network should not be an issue. Network issue ಎಷ್ಟಿನ ಹೇಳ್ತೀರಾ? Make sure that these are not the reasons for from coming classes. Okay.
Okay, sir. Sorry, sir.
Okay. What to say? Okay. How many times you people say sorry to me? That will not work out, no? We need to find out some solutions so that these things doesn't happen. Okay, done. Okay, let me now with me it is Nivedita, no? Okay,
Yes, sir.
Nivedita, we'll just see this problem. Where do I maximize this? Okay, let me for the time being. Okay, let us look at. First, we already looked into that problem. Nivedita, look into this figure 6.41. All of you copy this figure 6.41. 6.41. All of you write this. Let me also write. Let me also write 6.41. Sorry. Where do I, how do I maximize this? No. Okay, here. 6.41. Just copy this 6.41. This one. Let me write that. It is 6.41 problem. Here it is. If I'm correct, this is all of you mute your microphones except Nivedita. Don't do any mischief as you used to do in your first year, because you're all famous for. Okay, could all of you write this? Nivedita, are you done?
Yes, sir.
Are you done with the copying of that circuit?
Yes, sir.
I have written.
Yes,
Okay,
sir.
let us see what is that 6.41 figure corresponds to. See here, uh, the statement for that particular 6.41, no? Here, this one. See, 22. Assume lambda equals 0. Compute W by L of M1 in figure 6.41 such that device operates at edge of saturation. Just read it. 22. This one.
Assume lambda is equals to 0.
Hmm.
Compute W by L of M1 in figure 6.41
Hmm.
such that device operates at the edge
Edge
of
of
saturation.
Meaning in this circuit, I need to find out what is W by L of this transistor so that this transistor operates at edge of saturation. Edge of saturation. What all things that is commonly given? Kp of N MOSFET, that is mu N into Cox, is assumed to be 200 microampere per volt square, and then VTO is equal to how much? How much? Correct?
0.4.
0.4 volt. Now the question asks this: you have to find the value of W by L such that it operates in verge of saturation. How do we proceed? Okay, let me explain. Okay, how do we start doing it? Now, to solve this problem, no other information is required other than what you learned so far. So nothing else, nothing extra is required now. So now you can see that it is operating at edge of saturation. Correct? Hello.
Yes, sir.
Okay, now it is one more thing that is said is lambda should be equal to 0. Okay, for the time being, let us
Yes, sir.
not worry about what is this lambda because we have not discussed this one. Now, since it is at edge of saturation, shall I take ID as equal to ID sat
ID
because it is
sat.
at edge of saturation? Because edge of saturation is this, so you are here. So meaning that okay, at this point current is already in ID sat. Correct?
Yes, sir.
Correct? Okay.
Yes, sir.
Now the point is this is ID sat. ID sat is equal to what is the expression?
1 by 2 Kp
Hmm?
W by L VGS minus VTH whole square.
Correct?
Yes, sir.
Is the equation. Out of this, what all things we know? We know this, we know this, we know this, because this is known. Correct?
Yes, sir. Yes, sir.
I don't know this, I don't know this also. Am I correct?
Yes, sir.
Because when two unknowns are there, I can't solve it using a single equation. Correct?
Yes, sir.
Okay, now how do we
Yes, sir.
proceed then now? Now, it was said that W by L should be such that it is at verge of saturation. Correct?
Yes, sir.
Now, when it is at verge of saturation, in this expression, in this circuit diagram, what is VDS sat here now? For this, what is the value of VGS now? VGS how much from the circuit?
VDS,
VGS.
VGS 1 volt.
1 volt. Perfect. How much is VTO? 0.4.
VGS 0.4 volt.
How much is VDS sat then? Is it 0.6? 1 minus 0.4 estimate? 0.6. Correct?
Yes, sir.
Okay, now VDS at is 0.6. Now, what do you mean by MOSFET should operate at verge of saturation? Does this voltage should be 0.6? Correct?
Yes, sir.
For this voltage to be 0.6, shall I write the KVL expression for this one? Shall I write it as VDD is equal to ID into that RD plus
Uh,
VDS sat. Correct?
yes, sir.
So is it 1.8? So out of this, what all things you know here? Do you know what is VDD? Okay, let me just hold this because of camera coverage. Do I need VDD? 1.8 I know.
1 point.
Do I know RD? 1 kilo.
Yes, sir.
I know 1 kilo. Do you know what is VDS at?
Yes, sir.
0.6. In this case, I don't know only ID. Can I find ID now?
Yes, sir.
How do I find ID? I will find ID. So I will rewrite this equation. Can I write ID is equal to, because in this expression ID was not known. Because if you want to find what is W bell, ID should be known. No? So we are
Yes,
trying
sir.
to find what is that ID using the other equation of this circuit diagram, because it is said that it should operate at verge of saturation. Correct? It was said that it should operate at verge of saturation. Verge of
Yes,
saturation
sir.
requires a voltage of 0.6. If this 0.6 is dropping here, then out of 1.8, 1.2 volts should drop here. Am I correct? Hello.
Yes, sir.
See, here you got 1.8 volt. Out of 1.8, if you want to keep this at verge of saturation, required voltage is 0.6. How much is the remaining voltage should drop
Yes, sir.
across across RD?
0.2.
0.2. So shall I write using this expression, ID is equal to VDD minus VDS sat by RD, which is equal to now 1.8 minus 0.6 by 1 kilo ohm, which is equal to 1.2 milliamperes. Am I correct?
Yes, sir.
So now ID is known now. ID sat is equal to 1.2 milliampere. You have this expression, no?
Yes, sir.
So out of this, you are not knowing ID sat. Now it got to know. Can I find W bell?
Yes, sir.
So now what do you have? 1.2 milliampere is equal to half Kp W by L. How much is this?
WL.
0.6 whole square.
Yes, sir.
Correct?
Yes, sir.
Can I find W bell now? We can easily find, because Kp is
Yes,
also
sir.
known. Find out what is W bell. All of you find out what is W bell. Sorry. Done? Is anybody done with the calculation?
33.33.
3.33 is the ratio.
33.
33.33. So W by L is equal to 33.33. Now, I just want all of you to do it. So is it 33.33 is W bell?
Yes, sir.
Sir,
Okay, now,
33.33.
yeah, what you can do is, so I'll show you how to operate the calculator. Instead of taking this onto left hand side, putting all these onto right hand side, all those things you can just forget it. So let me show you. Okay, can you all see my calculator? Hello,
No,
Nandit.
sir.
Oh, yo, is it
Sir.
not visible? Calculator?
Yes, sir.
Visible.
Hey, visible, no? Calculator.
Screen is
Yes, sir.
Now it is visible.
my screen.
Your screen?
Here
Hey,
network problem, sir.
oh,
My
okay, okay,
screen is not
okay,
visible.
okay, okay. Fine. So for others, okay, this screen is visible, no? Sorry, my calculator. Hello.
Yes, sir. It is
Yes, sir.
visible.
Now fine. Okay, now you can see what I'll do is, so I will use this equation as it is and then calculate what is W bell. So let me start using it. See, now I'll type 1.2 exponential minus 3, because that is your 1.2 milliampere. See, this equals, I will say all of you who are all having this type of calculator, there is something like alpha. Alpha equals, got it? Let me just redo it. 1.2 exponential minus 3, that is 1.2 milliampere. Alpha equals is exactly this equation. Then 0.5 into 200 exponential minus 6 into, this is a parameter to be found. This is a parameter to be found. You make it as alpha A. Alpha A is an unknown parameter because you don't know the value. Type it as alpha A. Press on alpha, press on this A. There is a pink color letter ABCD, no? Nivedita, can you unmute yourself and then speak to
Yes,
me?
sir.
Are you getting it? Hello.
Yes, sir.
Okay, now that is done. Shall I say this is 0.6 whole square? Done. Now we
Yes,
can
sir.
see I have edited the equation as it is. I have entered this equation as it is. You can see if I can read this equation, can you see it is 1.2 e power minus 3, that is milli, alpha equals 0.5 into 200 e power minus 6 into a, that is alpha a, into 0.6 whole square. Now I want to get that value of a. So for that you have to do shift cal twice. Are you getting 33.33?
Yes, sir.
Shift cal twice. Shift calculator, shift cal. So it is so easy. Meaning, given an equation, you substitute the equation as it is. If there is an unknown parameter anywhere, any part of your anywhere in your equation, don't rearrange the equation. Usually what you do in your math class is you will do W by L is equal to 1.2 milliampere divided by half into Kp 0.6 whole square. You do, no? Am I correct?
Zero.
Am I correct? Will you do like this, Nivedita?
Yes, sir.
So no need to
Yes,
do
sir.
all these things. No need to do all these things. Of course, I want to avoid you people simply writing unnecessary things. In this equation, you type it as it is, and you get the value of what unknown parameter. In this case, it is omega. Sorry, W by L, which is nothing but 33.33. Is that fine?
Yes, sir.
Okay. I will repeat this. I will repeat this. So, what is to be found, Nivedita, in this equation?
1.2.
What is to be found?
Hello, sir.
What is to be found in this equation?
W by L.
So I will edit the equation as it is. 1.2 exponential minus 3, because that is milli, alpha equals, because there is a equals here. Can you see there is a equals here? So since there is a equals here, I'm just putting it as alpha equals, and then 0.5, that sorry, okay, 0.5 into 200 exponential minus 6 into zero point 0.6 whole square. Shift cal
Whole
shift.
square.
Oh, 1 second. There is, madam, maximum. Oh, 1%. Okay, just a minute. I will 1.2 exponential minus 3 alpha equals zero point 0.5 into 200 exponential minus 6 into zero point 0.6 whole square. Shift cal shift. Hey, one second. Yes. 1 second. 1.2 exponential minus, oh sorry, it is alpha equals 0.5 into 200 exponential minus 6 into zero point 0.6 square into alpha a shift cal twice 33.3. Got it? Okay, let me know from your friends how many of you could able to calculate this. Okay, put in the chat box. Okay, how many of you can able to recording started. Rupashi, thanks for that. Okay, now, okay, all of you type, could you able to get this? Of course, this is very handy, may not be such handy over here. Okay, even though if you're not getting it, let me know. So Ayush Kumar says, okay, he didn't get it. Let me see. What is this problem? One thing is that I don't know how to do it in the other calculator. So there is one more type of calculator. I don't know the number. So unfortunately,
Sir, how to get alpha is equals to?
see who is speaking now?
Yes, sir, other type of calculator
Madam, okay.
that you are using.
No, I know how to use this calculator. Do you have similar to this or a different one, a silver colored? I think you have a different one or similar to this.
Sir,
Is it this type only?
yes, sir, silver color.
Maybe sometime later I'll let you know. So because I don't know how to operate that calculator, maybe I'll just ask one of your seniors and then let you know how to use them. So sorry for those students who are using other type of calculator, but using this Casio of this series, I know how to operate. For others, those who have a calculator of a different type, a silver colored one, I don't know the make as well as the part number of that one. So at least those who have this type Casio, are you getting it? So let me see. Okay, how many of you responded? Not all of you responded. It is someone is raising the hand. I don't know why she is raising the hand here. Okay, different types, sir. Sorry. Okay, maybe. Now, those are not getting. If you are using a different type, maybe by tomorrow I'll let you know. Okay, I'll just learn from your seniors and then let you know. So there's no point in. Okay. Okay, fine. So what we'll do is we'll go back to that what 20 sim. Sorry, LT spice and then show you whether this is true or not. Is this visible now? No, LT spice is not visible. No, Nivedita.
No, sir.
Okay, let me share that also. Share content. Where is that? Okay, this is here. I think now it's visible. Okay,
Yes,
now.
sir.
Okay, now let us do the same thing. Okay, what was the problem said? The problem said that it is having. Okay, only this. So this was 1K, no?
Yes, sir.
This is 1K, and then W by L that what we found was 33.33. Am I correct? Hello.
Yes, sir.
Let us make this 10 micro, and if I make it as 333.33, will it be fine? Does the ratio become 33? Hello.
Yes, sir.
Okay. Shall I take out this? I will take out this, this also. Let me use a battery. Battery is there on F2. I'll take a voltage source. And what are the voltage we had, Nivedita? 1 volt.
1 volt.
Is this 1.8?
Yes,
Sounds
sir.
so fine. So what should be
Yes,
the
sir.
current flowing now?
Yes.
As per our calculation, what should be the current? Ishtama. How much is the current?
1.2.
1.2 milliampere. Volt alarm. This is milliampere.
Yes, sir.
Okay. Now
Milliamp.
let me just go there. Is this fine? KP 200 VTO 0.4. Hello.
Yes, sir.
Shall I
Yes, sir.
run? Shall I run?
Yes, sir.
Can you see the current is? Let me take out everything except let me just delete them. This I'll delete, this I'll delete, this also I'll delete. Can you see the current is? Can you see current is 1.199, almost close to 1.2 milliampere. Can you see here? 1 point here. 1.19.
Yes,
Nivedita.
sir.
No, you have to be
Yes, sir.
responsive.
Yes, sir.
Can you see it is 1.2 and there it is almost 1.19. They're same, no? Correct?
Yes, sir.
Now, is the MOSFET operating at verge of saturation? Because W bell, I made it equal to 33.33. Correct?
Yes, sir.
Can we
Yes.
find what is VDS here? What should be VDS now? for verge of saturation?
VDS is 0.6.
Shall we measure? See here. Is it not 0.6? See here. 600 millivolt. Correct?
Yes.
It's
Yes,
perfect,
sir.
no? So are you
Yes, sir.
satisfied with the problem solving? So at the starting point, we find, oh, it is so difficult. Correct? The
Yes, sir.
problem said, what was the problem? Assume lambda equal to 0, compute W bell of M1 such that device operates at edge of saturation. It looks so complicated in the beginning, but when you just go down to the equation, it is so easy. Correct?
Yes, sir.
Is it easy?
Yes, sir.
Looks easy?
Yes, sir.
Easy or difficult?
Easy, sir.
In the beginning, what did you felt? 6.41? It was looking so difficult, no, to start with. Let us say what is 6. Okay, let me take one more student with me who is there with me now. I'll take a different student. Thank you, Nivedita. Let me take Tanuja itself. Tanuja, come.
Yes, sir.
Tanuja, no, why or don't be afraid of it. Okay, now fine. So what is 6.42? This is 6.42. Maybe all of you can rewrite the circuit diagram. Let me also write the circuit diagram. What is the circuit you have? The circuit what I have is, let me write here. Okay, let me write the circuit what I have. Let me just put it on this side, this on this side. Okay, where is this? 6.42, no? 6.42 is this. This is the circuit. Let me write that. So this is 500 ohm. This is this 1 volt. No, I'm doing it very slowly. So don't think that I'll be doing like this in coming classes also. Because unless you get used to how to use the calculator, it is difficult. That's why I'm just going very slow. This is 1 volt. Ground. W value is already given. This is 500, 1 volt. Let us see what the question is. This is 6.42 figure number. Let us go back to, is it done, Tanuja?
Yes, sir.
Okay, let us go to the problem, actual problem. What is the problem is, where is the problem? 6.42, where is 6.42? Here. See, in figure 6.42, what is the minimum allowable value of VDD if M1 must enter the triode region? Now they are asking what is the value of VDD itself. What is the minimum VDD allowable? What is what is minimum allowable value of VDD if M1 must not enter triode region? Read the question.
Sir, in this figure 0.42, what is the minimum allowable value of VDD if M1 must not enter the
Triode
tribal
region.
region?
Triode
Assume that.
region, assume lambda equal to 0. Fine. Now actually this VDD is not given. I don't know why I wrote this. So this is VDD not given. You have to find out what is the minimum value that is required to keep the MOSFET still in saturation. It should not be allowed to go to triode region, means it should be at the verge of saturation. Correct?
Yes, sir.
Am I correct?
Yes, sir.
Now the point is, now in the previous question they asked what is the value of W bell. Now in this problem they are asking what is the
VDD.
minimum allowable VDD to keep the MOSFET at verge of saturation. Correct?
Yes, sir.
Now shall we start with ID expression? Because they are talking in terms of not to enter triode region, means it should be in saturation.
Okay, sir.
So shall we start now? What
Yes,
do
sir.
I write the tell me the expression for ID sat.
So 1/2 kp W by 3.
One second. W by 3.
Sorry, sir. W by L.
W is width, L is length. WL into VGS minus VTO whole
V
square.
whole
Correct?
square. Yes, sir.
Do we know this? Half we know. Do we know KP?
Yes, sir.
Yeah, okay, okay. Why you're afraid? No, you're there
No.
comfortable at your house. WL you
Yes,
know.
sir. Yes, sir.
Do we know VGS?
Yes, sir.
Do we know VTO?
Yes, sir.
Can I find ID?
Yes, sir.
You can find out. Find out. Shall I do it?
Yes, sir.
You also do. 0.5 into 200 exponential minus 6 into 10 divided by how much is 0.18 into 0.6 whole square. Is it 2 milliampere? When I can do so fast, why not you people?
2 million.
1.99.
1.998.
How come it is 1.98?
2
Okay,
milliampere.
2 milliampere.
2 milliampere.
1.99 ಹೆಂಗ್ ಬರ್ತಪ್ಪ? Okay, almost close to it is equal to 2 milliampere. Correct?
Yes.
So we are done with what is VDS set. Correct?
Yes,
VDS
sir.
said this is not the answer. The answer is we need to find what is VDD minimum required to keep the MOSFET in saturation. Correct?
Yes, sir.
So what I'll do? How do we proceed now from now onwards? After we find ID, what shall we do? Shall I write the expression for this now? Shall I say VDD is equal to, what is that? ID into
ID,
RD
RD,
plus VDS.
VD salt.
VDS in general.
Okay,
In
sir.
general. Suppose if this has to be at VD sat, they are asking what is this minimum voltage. Am I correct?
Yes, sir.
So how much is this minimum? I don't know. But do we know what is ID?
Yes, sir.
2 milliampere.
2
How much
milliampere.
is RD? 500 ohm. How much
500.
is VDS sat?
VD is 1.0. Sorry, 0.6.
0.6. VDS sat, how did you find? How did you know 0.6? How?
0.6. Sir, by applying IDS salt.
Ayyo. It is so easy, no? VGS minus VTH. VGS is 1, VTH is 0.4. 1 minus
Yes.
0.4 is 0.6. You know, by applying what?
No, sir.
No, no, what's your name?
Tanuja.
Tanuja, it is not that difficult. So,
Okay,
I
sir.
did ask you what is this VDS at. VDS at expression is, what is VDS at? VGS minus VTH. It is so simple. You know this as VGS as 1 volt because VGS is 1 volt. No, here. Can you see here? Hello.
Yes, sir.
VGS is 1. VTH is how much? 0.4. 1 minus
0.4.
0.4 is 0.6.
Okay, sir.
So it is as easy as possible. So is this 1.6 volt?
Yes, sir.
So what is VDD minimum?
1.6.
So if you operate this circuit, with VDD as 1.6 volt, this as 500, with this as 10 by 0.18, with VGS as 1 volt, the MOSFET will be there at the verge of saturation. If you keep it more than that, what happens? If you keep it 1.8, will it be still in saturation or will it be in a different region? Now this is minimum voltage required. Suppose if you keep VDD as equal to 2 volt, will the MOSFET be still in saturation?
No, sir.
Where it will be?
It will be in.
No, we have been asked to find minimum value required to keep the MOSFET in saturation. See, we kept this as 0.6. That is what is minimum required. And ID for to be in saturation, it is 2 milliampere. When it is in saturation, it's 2 milliampere. RD is 500. So this gave us 1.6 volt. Instead of keeping VDD at 1.6, if I keep it at 2 volt, does the MOSFET remains in saturation or linear?
So saturate.
Why? Because it is more than 1.6.
Yes,
Suppose
sir.
if this is 1.5, can the MOSFET be in saturation region?
No, sir.
It will not be. It will not be. So minimum voltage required is 1.6.
6.
Correct?
Yes, sir.
Shall we? Of course, I'll just leave it to people. You can make this equal to 1.6. Shall I make it? I'll make it 1.6 here, and then I will make this because I need to change the W bell. So W bell should be 0.18. Maybe let me make it as milli, whatever. And this is 10 milli, no?
Yes, sir.
W bell is 10 milli. Milli or micro, you can give whatever because the ratio should be so. This is 1. Everything is fine. If I run it, current should be 2 milliampere, no? Can you see
Yes,
current
sir.
is 2 milliampere? Can you see this is 2 milliampere? Where is that? Oh, how much is this W bell? Okay, sorry, this should be 500 ohm. Resistance should be 500, no?
Yes, sir. Yes.
This is 500. Now if I run it now, can you see current is 2 milliampere? See? Tanuja,
Yes,
is the
sir.
current 2 milliampere? How much is VDS? 600.
So 6 amp.
600. Correct?
Yes, sir. 6 amp.
If I
Yes.
keep it 2 volt, if I run now, is the current still 2 milliampere?
Yes.
This is 2 milliampere, no?
Yes, sir.
Does VDS is 1 volt? See? Hello.
Sir.
Does this make VDS more than 0.6?
Yes, sir.
So is the MOSFET in saturation linear?
Saturate.
It is in saturation region. Now
Yes,
instead
sir.
of 1.6 and sorry, instead of 2, if I make it 1 volt, what will happen?
Sir, it's a lean.
It goes to linear region. See the
Yes,
current.
sir.
Current is no more in linear. It is no more at 2 milliampere. Correct?
Yes, sir.
How much the current? It is 1.46. And you can see the voltage. Voltage is also not
Not it.
not even at least 0.6. It is 281 millivolts. Now the MOSFET is operating in. See here. Now the MOSFET, it was supposed to, if it is operating in what saturation region, this would have been 2 milliampere. Since it is operating somewhere here, this is 600 millivolt minimum required. Since it is operating somewhere here, the current is 1 point. How much is the current? Current is 1.46. Current is 1.43. This is 1.43, and this is around 280 some millivolt. You can see this operates in which region?
So saturate.
This one.
Sorry, linear. Yes, sir.
Where are you there in the class, or are you talking to someone?
No, sir.
Then how can you go to saturation region when the current is less? This is VGS
So
is equal to
linear,
1
sir.
volt. Okay, done. Fine. Let us go to next problem.
Sir. Sir, the
Yeah.
question that we had to calculate the minimum voltage. Sir,
Minimum.
if the
Yeah.
question,
Hmm.
sir, if the question would have been that what is the maximum potential to keep it in the in linear, then will the things change?
It will be same, no? Maximum voltage to no. Usually, why they call it as when you actually do the problems, you'll get to know that our intention is always to keep the MOSFET at the saturation region. Nobody wants to operate the MOSFETs in linear region, especially in analog applications. If I want to use the MOSFET to its better what extent, I want to keep my MOSFET in linear region, and it will never be said to ask the maximum possible value of voltages, because if you are using maximum voltage, the power dissipation is more, and nobody will prefer that. They always look for what is the minimum voltage that you can able to do. So the optimum design always mean for, okay, what is the minimum value that I can able to get it. So when you are when you go to market, will you bargain for minimum price or maximum price?
No, sir. I asked what will be the maximum voltage to keep it in linear?
That's what by I am asking you.
Yes.
Linear region, you don't want to be there in linear region. Of course, for this particular problem, to answer your question, not entering linear region with minimum voltage is exactly equal to not entering saturation region with maximum VDD.
Okay, sir.
Is it not?
Yes.
Because when you're there at the verge, it is the minimum for your saturation and maximum for linear.
Okay, sir.
Correct?
Okay, sir.
You'll always look for minimum voltage in case of saturation voltage.
Thank you,
Okay,
sir.
okay. Okay, let us see this problem. Okay, what is this? 6.4, 6 point. Okay, it's almost maybe why don't you people try these two as assignments? Challenging one, 6.44 and 6.45. If you can solve it, very fine. Otherwise, we'll solve it tomorrow. Just copy these two questions. Maybe you can take a screenshot of it, or just write it. There's nothing to worry. Just write it because you don't have any class after this. Do you have any class?
No, sir.
Oh, then today's job is done now. So free. Happy to attend the classes like this, or will you people like to come to college? Tanuja, happy sitting at class and okay at home and then visiting to the class, or prefer to come to college?
Sir, both.
Both. In the morning in college, in the afternoon you can be there at home. Okay, fine.
Yes.
I'm simply joking. Copied these two questions. Sorry, these two circuits. 6.44, 6.45. They're actually in page number 340 of the one what I shared with you people. What is that? The doc file. The page numbers are this page number. The page number of your PDF, it is not this page number, because on the sheet it is given as 316. The page number that I shared is actually this number, because this you can edit here. So you can actually type and then go to that particular page. If you are done with this, I'll go to the exact problem. What is that is, this is 644 and 645, no? 6.44, 6.45. Where is that? They are here. This is 6.44. Okay, these are the 26 and 27 are the problems. Correct? Tanuja,
Yes, sir.
copy this. Just read this. 26.
Compute the value of W by L from M1 in the figure 0.44
It is not
for the
0.4. It is
bias current.
6.44, no? 6.44.
6.44 for bias current of I1. Assume alpha is equal to 0.
Okay. Here, okay, they are not given the value of I1. You just consider it as a general I1 value and then give the equation. Then calculate the bias current of M1. This is you are asked to find the bias current of I1. What the bias current means? What is the current drain current? Here also bias current is I1. Sorry, ID, the drain current. Okay, maybe why don't you take this also? Let me see what is 6.47 is. 6.47, what is that? 6.47. Yeah, 6.47. You have some numericals. Maybe this is interesting to you. Just copy this question 29, because 26 and 27 are in general, because they don't have the numeric values. You may find it okay how to do it, but 29 is a numerical problem. For here you take lambda equal to 0 for the time being. All of you take this lambda as 0, because we not discussed this lambda so far. Take it as 0. Done? Tanuja?
Yes, sir.
Read this with lambda as 0. Read this.
Assume W by L is equal to 10 by 0.18 lambda. Lambda is equal to 0 volt and VDD is equal to 1.8 volt. Calculate the drain current of M1 in the figure 6.47.
6.47 is this. Where is 6.47? It is this. This 6.47. Did all of you write all the three figures? 6.44, 6.45 and 6.47. So I'm looking at the solution for 6.47 because you have a numerical values. You give me for 6.47. Okay, then thank you so much. So I'm late by 5 minutes. Sorry for that. So just a minute, before you leave. Let me just scroll through your participants list, and then please don't go away. Let me just scroll through the participation list. 49 of you are there, that is including me. 48 students. 1 second. Okay, I'm done almost. Okay, done. Thank you so much. You can leave.